right, we're going to do the second free response problem from day number 6. They give us an equation of a curve, and they tell us the derivative is always between here. Now, this is something that is kind of an odd thing to share. It really doesn't come up until the very end, but it kind of can throw you off at first when you see it. So part A says, show that the derivative of this dy dx is equal to 2 over 2 minus sine. So what I would do is I would distribute this, make it 2x minus 2y first, and then let's just go ahead and take the derivative. So derivative of 2x is 2 minus derivative of 2y, 2 dy dx equals derivative of 3, which is 0. Derivative of cosine is negative sine, keep the inside the same, times dy dx. All right? So now if I add this 2 over, I get 2 equal negative sine y dy dx plus 2 dy dx. We can factor that dy dx out. So I get dy dx times, and I can rearrange that to 2 minus sine y. And I can divide, and so there's dy dx equal to 2 over 2 minus sine y. All right, they gave us 1 point here for the first implicit differentiation, and then 1 point for getting you to here. In a problem where they say to verify or show, you do have to show all of your steps. You can't cheat your way through it. But as long as you showed these steps clearly enough, they'd give you 2 points for that. Okay. Part B says, for this, the point P on the curve has a slope of 1. Tangent line has a slope of 1. That means it has a derivative of 1. So we just said this is the derivative. So what we're going to do first, and I'll do it over here, is we're going to set that derivative equal to 1. That's what is being implied here. So 2 over 2 minus sine y is equal to 1. If I multiply by 2 minus sine, I get 2 equals 2 minus sine y. And if I subtract 2, I get negative sine y equal to 0. So really, sine is equal to 0. So what I'm trying to think about is between negative pi over 2 and pi over 2, when does sine equal 0? And that's when y equals 0. Okay? So they gave us a point for finding this out here. Okay? Now what we had to do is we got to find the coordinates. So I got to find the x value as well. And in order to do that, now that I know y is 0, I come back to the initial equation and I put 0 in for y. So we're going to get 2 times x minus 0, so 2x, equals 3 plus cosine 0, which is 1. So 2x equals 4. Divide by 2, we get x equal to 2. So the coordinates are 2, 0, and we get a second point for that. So point for setting up the initial equation here, and then a point for the final thing. It's not too bad. Part C says find the concavity. Concavity is your second derivative, right? We deal with second derivative. So what it wants us to do is to take the derivative of this and see what we get. So if we take the derivative of that, we can do it as a quotient rule if we want. So it'd be 2 minus sine y bottom times derivative of the top, which is 0, minus top times derivative of the bottom, which is a negative cosine y times dy dx over bottom squared. All right, so this part cancels out, and I'm going to have to replace this with that 2 minus. So we're going to end up with negative or positive, negative times negative, positive 2 cosine y times 2 over 2 minus sine y over 2 minus sine y squared. Now, they gave 2 points for finding the second derivative. So this is technically the second derivative. Even if you stopped here or wrote some silly answer afterwards, you'd get 2 points for doing that, either through quotient rule or another means. What we can do to make life easier for the third point is bring this to, since all of this is multiplying on top, we can go ahead and simplify it into 4 cosine y, and then let this 2 minus sine y drop down and make that 2 minus sine y cubed. Now, from negative pi over 2 to pi over 2, cosine is always positive. It's quadrants 4 and 1. So I know I'm going to have a positive value there. And sine is never bigger than 1, so 2 minus sine will also always be positive. So this second derivative is always positive. Therefore, y is concave up, or the graph is concave up. Maybe that's a better way to say it. The graph is concave up. And if we had said that, if we showed the positive, or whatever, that gave us the third point on that. Okay. Then we come to one of the goofiest questions I've ever seen on an AP exam. It says, let y be this and differential. Use the mean value theorem to show this. Was something kind of crazy looking. So first up, they asked about mean value theorem. So let's kind of apply the mean value theorem, right? Mean value theorem says somewhere between 2 and 2.1, the derivative at some value has to equal the average rate of change, f of 2.1 minus f of 2 over 2.1 minus 2, which is 0.1. Okay, that has to be true. Then we're also told, back up the beginning, and this is where this comes in, that the derivative is always between 2/3 and 2. So the derivative, really any derivative, has to be between 2 and 2/3. So here's the deal. They gave you a point if you just at least listed the mean value theorem. If you saw mean value theorem and you at least wrote it down, you got a point for that. What we want to do is, since the derivative has to equal that at some point, what they were asking you to do is to put that derivative, or this mean value theorem, right there, and have 2/3 less than or equal to f of 2.1 minus f of 2 over 0.1 less than or equal to 2. And then to multiply by 0.1, or multiply by 1/10, which would give you 2/30 or 1/15, f of 2.1 minus f of 2, and then this would be 2/10 or 1/5, and that's exactly what we were trying to get to. That would give you your last point. Really a strange problem, but what they had on that AP exam that year.